Aquabots Command, Control, and Communication team. We were tasked with creating a swarm of drones capable of mesh communication, GPS guided movement, sensor data collection, and graphic user interface control in order to create a mesh network to control these drones that in the end will help to survey the oceans as well as provide sensor data on the overall ocean health. Hi, my name is Austin Greif. I'm a systems and industrial engineer, and I'm the team lead for the Aquabots project.
Hi, I'm LD Dukes. I'm a mechanical engineer, and I was the mechanical lead for this project.
Hi, I'm Stan Gulati. I'm the electrical lead on this project.
Hi, my name is Christian Gigante. I am the co-lead mechanical engineer for this project.
Hello, my name is Suwan Wong. I'm the software lead on this project.
Hi, my name is Garrett Fenderson. I'm an electrical and computer engineer, and I was the computer lead on this project.
In order to approach this problem, we broke our system down into three main parts: the embedded computer systems within the drones themselves, the software for the graphic user interface, and the hardware component of the actual physical drones.
So to accomplish the overarching goal of our project, we were tasked with buying 8 RC drones, which internally we were able to add Arduinos to each, being the brains of the embedded software. We also had 3 sensors, their main capabilities being to sense temperature, salinity, and pH in water while trolling around. And then the most important part of our project was the RF transceivers with mesh capability, which were used to communicate between the drones and back to the user at the command station.
First subdivision was our embedded system, which is the software that goes inside each drone. We started with a communication system, which means getting the XP radios to talk to each other and sending information to each other. After that, we focused on each component of a drone, which means bringing online our magnetometer sensor, our GPS sensor, our motors, our radar system, our water quality sensors, temperature, salinity, and pH. Once we made sure that those functions were working, we integrated them together into one final code, then made sure that everything is working together. Once we had that, we could start focusing on our navigation system, which involves a PID controller. So we get information from our magnetometer and our GPS sensor, and from that we can calculate our outputs for our motor and our radar.
So the final part of our system design is the computer software, and the computer software is composed of 2 components. One is the graphical user interface software that's written on C++ using the software called Cube Creator, and the other part is a Python program that's handling the communication to the drone between the XB modules. And the GUI will allow the user to see live sensor data, GPS location, bearing, and also be able to see the drone's location on a live map. And the user will also be able to interact with the map to zoom in, zoom out, and also select destination for the whole swarm or each individual drone.
To implement the components in our drones, first we needed a compact CCA. We did so by using a PCB. We then constructed a mount which could secure our final CCA within the drones, the 8 drones. And then we had to drill some holes for the drones to fit all the sensors and the cables as well. This process was done again for the 8 drones, and the goal was to basically reach our deliverables standards.
So for the final deliverables to the customer, we're planning on having 8 drones with RF mesh network capability and communication back to a central command center with a fully developed GUI to send sensor data from temperature, pH, and salinity to the user. We also are ensuring the waterproof capabilities of each craft.
So as you can see in the video, to test our GPS movement commands, we placed the boat in the water oriented away from its desired GPS destination. and once it was placed in the water, the rudder and motor automatically course corrected and started moving towards its GPS destination. To test our mesh communication network and our GUI, we set up a test with 3 separate drones and the GUI running on the laptop. And through the GUI, we sent a command to all 3 drones to rotate the rudder and turn on the motor, establishing that we have a working mesh communication network, and the GUI is able to correctly send commands. We verified that our drones are able to successfully read water metric data. We submerged the sensors in standards of water with varying salinity, pH, and temperature, and read that data back from the drone to verify we were correctly reading the data.
So our design process has gone through a lot of changes since the beginning. Our first design, or our first original prototype, was going to be 3 computer assemblies put together to test the mesh network communication systems. However, we learned very quickly that the supply chain doesn't always work the way you want it to, and we had to change our design from 3 computer assemblies to a single working drone that could then measure sensor data and communicate that through a basic radio that was not going to be our final mesh radio. However, we then ran into some issues with the compactness of our computer assembly and how it fit inside the boat. So we learned that we were going to have to redesign and reprototype our printed circuit board as well as our computer assembly in order to fit better with inside the boat. And then from there, the next step in prototyping was to create 3 of these working drones, making sure they were networking together, communicating well. And then from there, we would just expand onward to all 8 drones within the swarm. On design day, we plan on showcasing the effectiveness of our product by having a few drones inside of a kiddie pool that showcase their movement abilities, a few drones on the table with their sensors inside buckets of water in order to showcase their sensor capabilities, as well as a computer screen that shows videos of the entire swarm moving and showcasing some of the mesh communication abilities by reading the different nodes between drones.